Okay, in the meantime, you guys, if you have a question, this is the time to ask them, right? Giving a test to a group of students, okay, the grades and gender are summarized in the table. Now, what is ABC? Does anybody know what ABC is?
The
The
score.
grades.
The scores, right? So, how many students were in this test or whatever it was?
62.
62.
62.
62. Okay. So this is basically what you're going to be in the denominator. So find the probability that the student was a female and got a C. It's a female and got a C. So first of all, we're going to take, in Lumen, they make it easier because they give you a table. So when they give you a table, basically they make it a little simple for you. It's a female. So females are everything that you see here. All right. The student was a female and got a C. And this is everything that has a C. Okay. So does anybody have any idea as to what do you think is going to be it's a fraction, right? It's going to be a fraction because probability is always a fraction. Probability is a fraction that has to be between 1 and 0. So what is that? The word "and" is very important here because this tell you that you want two things, exactly two things. What are the two things that you want? This person has to be female and he has to have a C. Well, we know that the denominator is 62 because that's the total. But what is the number that will go on the top?
3.
Right. Because these are the only, this is the intersection. Basically, N is an intersection, right? Between the two things that you want. You want them to be C and you want them to be female. The only place that happens is here on 3. I don't know. Was that good enough
What?
explanation?
Yeah,
Okay.
yeah. So it will
So,
be
yes.
3 over 62.
3 over 62, I don't, if you divide 3 over 62, it's going to give you, the number, very close number to what you have there, which is, I think is 0.048 in my calculator, 38. So they give you, I don't know how many decimals. They don't say here. Apparently, according to the answer, you need all the decimals, right? But don't worry, in the final exam, if they don't tell you, I'm sure they're going to tell you how many decimals because they're going to take a look very closely at your questions and answers. They're going to be more careful. Lumen has a problem that sometimes they're not careful in to ask you how many decimals. Remember, the approximations are a little bit off, but I'm going to take a look at all your answers.
In
And
general, when they ask for probability, they want it in a fraction.
they want a fraction, right? Yeah.
Mm-hmm.
So the problem here is that they don't tell you. So, but it obviously in this case because we can see that the answer is better for us to write a number because the decimals is an irrational number, so we're never going to stop writing. It's too long. All right, so keep fractions with probability, but I'm always going to take a look at your answers. I'm going to go one by one, just in case you have a close approximation. I'm going to mark it right. But anyway, be careful because I never seen a final exam from them like this. I always seen it on paper.
Okay.
Okay. Does anybody have a different question? And please have questions. Otherwise, I
Is
don't know what questions you
Yeah.
have.
The
yeah.
final review, question 33.
Final review question number 33. Okay. So I gonna go here, and because I don't have the final review there, I should have in there. Mm-hmm. I'm gonna quickly go over here. It's click for lessons and PDF, and here we have the final review Number 33. It's a good idea that you have both, right? You study both the Lumen questions and the final review. All right, let's take a look at number 33. 27, 29, 30, 33. Okay, this question is, oh, it's only 34 questions. I forgot. I thought there were 39. That's pretty good. All right, let me copy that into our, and do something else. We need a new page. That's right. There you go. I forgot this system. It's pretty cool too. The only problem that I don't use is because it has this watermark. Okay, a researcher claims that the average wind speed in a certain city, I'm so sorry, is 8 miles per hour. All right, so let me start, remember outlining the important thing. This actually has a highlighter. So a researcher claimed that the average wind speed in certain city is my power. What would you highlight from the first sentence that I just read?
Average at 8 mile.
Very good. So I'm going to average is a very important word, and also 8 miles per hour. Okay, let me read the second statement. In a random sample of 32 days, the average wind speed is 8.2 miles per hour. That's the second statement. Now tell me from that statement, what would you highlight?
In a random sample of 32, the wind speed like the average is 8.2.
Okay, very good. So let's highlight those things. We need to put a random sample. Well, it's different color. Random sample of 32 days. The average wind speed is 8.2, right? So this is the other information that I have. The standard deviation. I am so sorry. I'm okay. I don't know what I ate. The standard deviation of the sample is this per hour. Standard deviation, and alpha is this. So this is basically what we need to do. So I'm going to start writing everything that we need to collect from all of this paragraph. And the first thing that I would probably like to collect is the information from the population, right? Population information. Remember, any information that comes from the population is called a parameter. Hopefully you remember that. A parameter. And I'm also going to collect information that comes from the sample. Right? What is that called when it comes from the sample?
Statistic.
Statistic. Very good. So I'm going to collect that. What information here comes from the population? If you take a look at that, comes from the population.
The average wind speed that is 8 miles per hour.
Okay, that's very good. So we're gonna have, what symbol do I use for that average?
Mu.
Mu. Oops, I put the wrong color because we're doing the purple for that. So let's do purple for that. Okay. So mu is going to be 8 miles per hour. What about the random sample? That goes in the other column. N is equal to 32 days. Oops. That's what happens when you're changing system. Sorry. 32 days. And the average wind, what is this average? And where does it go?
Sample.
And how do I symbolize it here?
S.
X bar. Very good. 8.2 miles per hour. The standard deviation of the sample, see, I don't need to tell you where it goes, is S, is 0.6 miles per hour. And now this is the testing information. So let's write that over here as testing information. The information that we need to do the testing, which is alpha 0.05. Could you tell me what percentage do they want to test at based on this number?
95.
95%. So that means that they're gonna have a 0.95 in the middle, and this 5% is gonna divide it either in one side or two sides. That's something that we need to determine based on this, okay? All right. Is there enough evidence to reject the claim? Okay, what is the claim? The claim is that it tells you here, the claim that the average wind speed in a certain city is 8 miles per hour. So that is the claim. This is the claim. Okay. Do you remember what would be the next step that we need to do that question?
T value or G value?
Okay, so the first thing that we need to determine is whether we want to have a t value or we want to have a z value. What do you guys think?
T value.
We want a t value, right?
Yeah.
Okay. So let's write. Why is it t value, by the way?
We don't have the standard deviation.
Since we don't have sigma, we don't need, if we don't have sigma, then we are forced to use t values. Okay. Do you remember what is the other step, the preliminary steps that we have to do?
Choose a method.
Choose a
H0 or HA.
A method.
A method, right? But before we do the method,
right.
which is very good, but before we do a method, we want to make sure that we know what h of 0 is and what is h of a, right? So that's very important. What is h of 0?
Equal to A. Mu equals A.
That's a simple one because always uses mu, and it's basically this number here, the population mean, the population standard deviation, or the population percentage. Whatever number that they give you, that's what goes here. Now, h of a is a little bit harder because we have to find out which symbol to use. Is it greater than, is it less than, or is it not equal than? So we need to read careful the last statement. Is there enough evidence to reject the claim, or in this case, h of 0? So what do you think is its h of a? By the way, it has to be mu. Now, what symbol do we use in this case?
Not equal.
Not equal. Very good. Now, I don't know if you remember that lesson when I told you this. If there is nothing here, it doesn't say greater than, less than, it has to, there's only one choice. This is the choice that you will always choose unless you see an evidence here that they use greater than or less than or at least that or greater than, whatever sounds like a inequality, that's what you're going to use. But if you don't see any inequality, then you're going to have to use the not equal to. Now we are ready to begin. We have the basic information. Now we're ready to begin. So I'm going to open a new page. Does anybody have any questions with this?
No.
So far, what's the first thing? You got to collect information from the parameter, the sample, the testing information, and then you decide t or z values, and then h of a and h of a. These are the steps that I've been doing so far. Please take that in your mind and keep them there. Now, the second thing that I want to do is that since I know this is going to be a t-value problem, so I need to create my diagram. Remember, how many diagrams did I create with you guys?
3.
3? No. Diagrams, not methods, diagrams.
2.
Ooh, I don't like that one. I'm just testing. Actually, I'm going to have to do it. How many diagrams did I collect it? Come on.
2.
Two. I only did two diagrams. One was from where? This is a little flat, remember? What was the diagram from? You remember what was the first diagram? Where does it come from?
From T value and Z value.
No.
Critical value.
Okay, by the way, that's supposed to be the same. It's just that I can't draw them. Yes, this is the critical value that comes from the calculator. I hope you remember. This comes from the calculator or table, right? Some people have tables. And this one, where does it come from? This is also a t-value because we decided to do t-value, but where does this comes from?
Statistic.
This comes from the sample, basically, right? Or the statistic. Very good. Sample or a statistic, the information that was given to us from the sample. Okay, so let's take a look at this one. What is it that let's put together all the information that we have. Remember, it was 95%. And what kind of test is? Was it a two-tail test or one-tail test?
Two-tail.
Right. How do you know it's two tails?
Unequal.
The word not equal, this, when you use not equal, that's two tails. If you use greater than or less than, that is one tail. So we are looking at a two-tail test. Two-tail test means that we are going to have to look at the information from the left and from the right. In other words, all my information has to be divided. Now, what is going to be divided? Alpha is going to be divided. Now, in this case, alpha was 0.5. But because it's going to be divided by 2, what do we get? What is 0.05 divided by 2? 0.025. So this area here is 0.025. This area here is 0.025. And the three together has to be equal to 1. 0.25 plus 0.95 plus that is going to be 5. So this value here is called T alpha divided by 2. And this one is also called T alpha divided by 2. Right? And we are going to get our number here. Now, this one, we're going to take a look in a moment, but we want to get this one first. We want to find out everything that we need, and we need a calculator from online calculator. We can find the critical value T. In other words, we have the area, but we don't have the T. This is an inverse problem. Now, let's go to the places where I say all these calculators for you. I put them in Google Classroom. So I'm going to go to Google Classroom for your class. Okay, give me a moment. This is statistics. So let's take a look at all the calculators that I give you. This is T-scores. This is not what we're looking for. This is T-scores. This is when you know the T-score and you're trying to find the area. But that's not what we're trying to do. This is the calculator to find the C critical values. This is what we would need if we're doing Z values, but we're not doing Z values. This is just to get the sample and the mean calculator. This is just a regular calculator. Now, if you look at the bottom, this is the calculator to find the critical value. So this is the one that we want. Okay. This is the one that I don't like. All right. Now, what is the significant level? But the calculator gives you the choice to enter the entire significant level. In other words, it gives you alpha. What is the significant level that we're working from this problem?
0.05.
Okay, I already have used it here. Now, what is the degree of freedom? The degree of freedom is the number of the sample minus 1. How many? What was the sample on this case?
32.
Very good, 32, and if we subtract 1, it will be 31. Now, here is this calculator divides the tails for you. If you're doing a two-tail test, Be careful. If you select the wrong one, then it's going to put all the information on one side, and that's not what you want. What kind of tell did we say that we had? What kind of test we said we was going to have in this case?
Two tail.
Two tell. So we're going to calculate, and then we're going to wait an hour in this calculator. All right, but basically you're not going to have a lot of this problem, maybe like 2 or 3 problems. But remember, it's only 15 questions. So if you have 3 of those are already giving you a lot of percentage out of all of them. So let's just wait for the calculator to have that. Oh, first commercial. Now, what is this going to show you if we look at the picture that that this website will give you is it's a picture with 2 tails, right? And there you go. This is the tail. So what is the T critical value? They call it T of C. We call it T of alpha divided by 2. It doesn't really matter what you call it. It's negative 2.04. Negative 2.04. So now we're going to go to negative 2.04, and we're going to write that number as we see it there. This is 2.04, and this is negative 2.04. Okay, perfect. Now we're going to go here, and we're going to get the T. This is from the calculator. This is very simple. This is on that calculator, and that's it. Now, this is simple also because we're going to use a formula. The formula is for the T value. The T value formula is X bar minus mu divided by the standard deviation. This is a sample. Remember, everything comes from the sample divided by the square root of n. That's what this number comes from. It's the same picture, but using the sample information. It's the same picture. So, of course, the numbers are going to be different. X bar, if you go back to the problem, it tells you what X bar was. X bar is 8.2. The standard deviation is 0.6. So we're going to use that information to put it here. X bar is 8.2. Mu, what was mu?
8.
8. Divided by the standard deviation. The standard deviation was 0.6. And the square root of the sample is 32. So now we're going to take a look at this picture here, right? Based on the information that we have, what is the number that we're going to get, right? So 8.2, I have to do it in my calculator, minus 8. The top one will give you 0.2, of course. And now I'm going to do the bottom, which is 0.6 divided by the square root of 32. That gives me a very ugly number, 0.10. But if you do it in calculator, you can do it in one shot. So I'm going to put that on a variable. I'm going to say 0.2. Do not approximate until the end, right? At this moment, I would suggest you use all of these numbers. Okay. I don't know if I did this right. Hold on. Can anybody do it for me just in case I don't want to make a mistake on this one? So double check that this is done correctly. I think I get 1 point. Does anybody have a calculator there? Since I'm using 2 decimals here, I'm going to use 89. Okay. Just double check later or now.
Yes.
So, okay, so these values are going to be 1.89 negative on this side and 1.89 positive on this side. So now, of course, the area is going to be bigger because it starts from 189. It doesn't start with 2.04. Right? So this area is going to be a little bit bigger. Now I need to go to the calculator again and do the opposite. Now I know this number, but I don't know the area. So I have to go to the calculator, different calculator. where I would need to find the area. I have the Z value, I have the T value, but I don't have the area. So let's go to the calculators that I have given you. Hold on. So let's go over here. And I think it was the first one that I gave you, the T-score. So see, I have the T-scores and I need to find the area. This is the one that I have. So I need to find the T-score. I'm using a T-score. The degree of freedom is 31. And what is the T-scores that I have? 1.81?
9.
8.89, 1.89. And now it's going to give me the area. Look at the area that it gave. Is that correct? Come on, I explained this last time. Is this correct? Is it going to be,
No.
look at the area. You can't just write the number without thinking. The area is
No.
0.96, almost 97. That's almost everything. That's not possible. This little piece is not everything. Everything here is 0.1. So 0.97 is very close. So remember what I said, what you need to do in this calculators online? I have to do something with this 189.
Minus.
Minus. I got to do the one on the left, right? If it doesn't allow me, so now it should, oh, I have to, this calculators, you got to do the whole thing again. You got to refresh. So 31 is the degree of freedom. Now it's going to be 1.89 and calculate. And now, oh, look, that makes more sense. 0.0341. By the way, 0.0341, do you think that that's a number smaller than the smallest number? Or can I use 0.0341?
You can use.
Yes, I can use it because it cannot be smaller than 0.0001. So this number, I can use it for my purpose. So I'm going to write it down because I'm going to forget. Okay. So I'm going to go back over here and I already know that area. I'm going to put it in different color. So I know that this area is going to be 0.0341 because the calculator went from here to here, and this is that area. If you're gonna go from infinity, this is infinity, negative infinity, and you stop here, the area is gonna be this, and because this is symmetric, now you can do the other side, right? Always do the left side first. Even if it's one tail test, you always do the left, don't do the right, because then it's gonna count more area than you have. Now, basically, you have everything that you need. Now, I'm going to put these two together. These two pictures I'm going to put together so that you can see clearly. I think you can already see the answer. There are 3 methods to doing this, and this is very important, like I said before, to remember. So I'm going to put the 2 pictures together. All right, let's see if I can. Okay, let me put this value first. I'm going to use a black color. So this was T negative 2.04, negative 0.4. And on the other side is going to be 2.04. Now I'm going to put the new ones that I found, the 89, 1.89, and I'm going to use a different color. Should I put it, let's go over here. Should I put it on the left or on the right of that?
Right.
Right, because negative 189 goes here. That I cannot teach you where the numbers go. Is 1.89, does it go to the left or 2.04 or to the right?
To the left.
To the left?
Left.
To the left of 2.04.
Ah, sorry. 1.89. 1.89. I was worried about that.
I was getting worried too.
So remember, this value, which is the critical value, is the one that makes the no, don't sit there area. This is do not sit there. Do not sit there. No. This is no. This number always produces a no. And this is the one that is going to decide where to sit. Should I sit in the no area or the yes area? It depends of the value. So we can quickly decide something here using the traditional method, which is one of the method, the traditional method. What does it tell you right away?
Do not reject.
Do not reject H0. Why?
Because because the number 1.89 is to the right of 2.04.
Yeah.
Well, or to the left, however you want to say.
Right. It's inside of the okay area. Anything here, it's okay. Everything okay is okay. Here is not okay. Not okay to be sitting there or to be sitting there. So you can see that the purple is good. So you can do this. By the way, you can use the traditional method and you say, well, I got my critical value from the calculator. I got my T statistics, they call this, or the sample statistics, and it's 189. I got the areas, I got everything that I need. I put everything together, and the traditional method tells me that I cannot use it. Now, can I use the other method, which is the what was the other method that the first one is called the interval, right? This interval, you got to be able to do all three, by the way. I'm not asking you to do all three. By the way, in the exam, that would be it. And you have to say, well, 189 is greater than 2.4 and 189 is less than 2. Which is the same thing as the interval method, but that's how you have to say. You have to be able to describe this. Because I don't know if they are, you can probably do a picture and take a picture of that with your phone and upload it, which I don't know that. We'll practice that on Thursday, I guess. All right. So what is the interval method? Is x bar minus the e value less than mu less than x bar plus e. Now this method is also, once you have all the information, this method is very simple. Because x bar is a number that they gave you. What was the x bar? I think it's 8.2. This is 8.2. They also gave you mu, which is 8. So basically, the only number you have to find is E. Now, E is the T critical value, T critical, times the standard deviation divided by the square root of n. Now, T value, I'm sorry here. Hopefully you're looking at this thing, it's too messy. What is the T critical value? You have it in all the pictures. What is the T critical value?
2.04.
All right, 2.04. This is the critical value, right? The first one that you did, times the standard deviation, which is 0.6 divided by the square root of 32. E will give you a value. I'm going to do it for you. Okay, or you can do it for me too. 0.6 divided by the square root of 32. That gives you that number times 2.04 gives me, I'm going to abbreviate only to 2 decimals because that's all I'm using. This is going to be 22. So I'm going to subtract 0.22 and I'm going to add 0.22 from this. And if I subtract 8.2 minus 0.22 from the left, I'm going to get 7.98. The 8 goes in the middle. And if I add 8.2 plus 0.22, I'm going to get 8.42. Question, is this true or not? Is 8 between 7.98 and 8.42?
Yeah.
Yes, this is true. What happens if it is true?
Do not reject.
Do not reject h of 0. Same conclusion. Okay. One more method. What was the other method? We have the p-value method. And the p-value, we compare alpha And what's the other value that we compare it to? You remember? It's called the p-value. Okay. Alpha, do you remember what was the alpha for this problem?
0.05.
Okay. And we're going to compare it to the p-value. What is the p-value? Can anybody indicate to me in these two pictures, what is the t-value? P-value.
0.0341.
Yeah, this is the p-value. The problem is that we have two p-values because we have two tail tests. So we have two. With the number is divided into two pieces. So we got to go back here. And it said, okay, it's 2 times 0.0341. So now we're going to compare these two values that I have here, 0.05, and 2 times that value, which is multiply everything by 2, that would be 0.682. Is that right?
Yeah.
Mm-hmm.
Yes?
Yeah.
Yep.
Okay, question. Which number is bigger?
P.
Right? If you look at this, take a look at the two decimals here if you're having problems. Well, because this is 2, I'm only going to look. This is almost like 7 because of the number. So this is 8, I'm sorry, this is 7 cents. This is 5 cents. So this is bigger. So the p-value is bigger than alpha. What is the conclusion?
Do not reject.
Same thing. We don't reject. I did it doing the 3 methods. Okay, method number 1, using the traditional method, the interval method, and the p-value. So we cannot reject the idea that the original idea, what was the original idea? That the average wind speed in certain city 8 miles per hour. So I believe that the average speed on that city is 8 miles per hour. 8 miles per hour. I do believe that. Okay, so that's basically what you are saying when you do this kind of exercises. Okay, I will hope that by Thursday, we're not going to meet tomorrow because we never have classes on Tuesday. We don't have, on Wednesday, this is the day of the class, which I'm going to give you off because I want you to do your exercises. Let me go back to that page, right? What exercises you're going to do? You're going to do all your homework from 1 to 11. Make sure you finish before June 4, I will say, before. And review your final exam before June 4. Now, week of attendance is Monday, we're going to meet, which is today. Wednesday, we're not going to meet. And Thursday, we're going to meet. And we're going to go like this. Next week, I will let you know because next week we only have, that's it. Next week is the only week that we have for you to study for your final. So maybe we introduce 2 more days. This week, I'm only going to give you 2 days, and 2 days is for you to do your homework. Please, don't do this to yourselves. I'm going to tell you something that I'm going to stop recording, and I'm going to tell you something. Today, I'm sorry, don't forget to take your attendance every day of the week except Tuesday. Doesn't matter whether we have a class or not. You have to finish. So let me stop recording, and I'm going to say something to you before you go. Okay.